Hi, my name is Teresa Bolger, and I'm a consultant archaeologist working with Rubicon Heritage Services. This is the third in a series of talks about archaeology in the context of construction projects and development control. Our previous talks outlined what archaeology is, why it's important, the legal framework for its protection, and how archaeology fits into the planning process. This talk will focus on archaeological methods and practices, what archaeologists actually do, and how they do it. Desk-based research and desk studies are a fundamental part of archaeological practice. Desk-based studies focus on existing knowledge and sources of information in order to understand the archaeology of a specific site or broader area. The key resources used for these types of study include designated site listings such as the RMP, National Inventory of Architectural Heritage, or RPS listings, the Excavations Bulletin Database and reports on previous archaeological excavations nearby, the Archaeological Survey of Ireland's published county inventories and surveys, as well as area or site-specific surveys such as the Survey of the Megalithic Tombs of Ireland. Historical mapping and aerial photographs are another source of information, as well as local journals and heritage publications. Archival records, notably the archive files of the National Monument Service and the topographic files held by the National Museum of Ireland, can also be consulted. Desk-based research informs archaeological works carried out at all stages, but it forms the core of certain types of studies that are carried out in advance of planning applications. In the case of small to medium developments, this would generally be what is referred to as a desk-based impact assessment. For larger developments and infrastructure schemes, desk-based methodologies underpin a number of graduated assessments, namely constraint studies, options appraisal, and environmental impact assessment. A number of different survey techniques form part of the archaeology toolkit. Site walkovers or site inspections are just what they sound like. The archaeologist, or a team of archaeologists, literally walks over the subject site or lands. The purpose of this is to look for features or conditions in the ground that might indicate the presence of previously unrecorded archaeological sites. This might include low relief earthworks, patterns in field boundaries, or visible artefacts in ploughed fields. This kind of survey usually also includes the inspection of any known archaeological sites nearby in order to assess if the proposed development under assessment would have any indirect impacts on the settings of such sites. Walkover surveys are a standard part of the types of pre-planning studies mentioned earlier: desk-based impact assessment, constraint studies, options appraisal, and environmental impact assessment. They complement desk-based research. Depending on the requirements of a particular project or its aims and objectives, archaeologists may also employ more specialised field survey methodologies. An example of this would be plough zone field surveys. This type of field survey can only be undertaken on recently ploughed lands and involves a systematic walkover survey to identify artefact scatters. Such scatters can indicate where the plough has disturbed underlying archaeological features and may result in the identification of a new archaeological site. Another example would be detailed topographic survey. That is a high-resolution geodetic survey. This kind of survey is most commonly carried out to try to identify the extent of a known site where it has at least some upstanding remains. This type of survey uses standard geodetic survey equipment, total stations or GPS survey kits, though newer technologies such as aerial drone surveys and LiDAR can also be used to similar effect. In addition to consulting archival aerial photographs, archaeologists can also engage in or commission project-specific aerial surveys to search for new sites or to define the record for an existing or known site. Aerial drone surveys are increasingly deployed for this purpose, replacing helicopter or light aircraft flights. Geophysical survey techniques can help archaeologists identify potential archaeological sites that cannot be seen on the ground. They can also enhance our understanding of the potential extent and complexity of known sites. Geophysical survey techniques include terrestrial methodologies such as gradiometry, resistivity or ground-penetrating radar, and underwater techniques such as side-scan sonar. They are what we term in archaeology a non-intrusive form of investigation. This means that these methods can indicate the presence of archaeological features that are subsurface with no visible remains without any disturbance to the subject site. Geophysical surveys can be carried out across large areas relatively quickly, particularly with modern cart-based sensor systems. It is generally best suited to greenfield sites, but certain techniques, notably ground-penetrating radar, can be effective in an urban setting also. However, it is not an exact science. Not all subsurface archaeological features will produce a geophysical signature, and the types of potential feature that can be identified is dependent on the geophysical technique used. Further intrusive investigation is usually needed to confirm the exact character and date of potential new sites identified through geophysical survey. Site-specific conditions can also affect the applicability and reliability of geophysical survey techniques. Sites need to be open and clear, with vegetation or grass cover cut down. Geophysical survey is not possible on sites currently under crop or with dense or deep vegetation. Sites that have been used for dumping or stockpiling of soil or have similar evidence for modern disturbance may also not be suitable for survey, as these activities will affect the survey readings and obscure the results. Very uneven ground or extreme slopes may also make sites unsuitable for survey. Underlying geology, such as volcanic type geologies, can also affect the reliability of survey results. An archaeologist or archaeological geophysicist will usually evaluate these issues on a site-specific basis before proceeding with survey work. Under the terms of the National Monuments Acts, all geophysical surveys require a licence from the National Monuments Service. These licences are specific to each individual survey. Geophysical surveys are best carried out in advance of a planning application, though they can also be carried out post-grant as part of the pre-construction requirements. The results of such surveys can be incorporated into desk-based assessments and environmental impact assessment. However, they can also form part of the mitigation strategies coming out of such assessments. Note, the use of metal detectors is considered to be a remote sensing technique and is regulated in the same way as other forms of geophysical survey. In all cases, use of a metal detector requires a survey-specific licence from the National Monuments Service. This is regardless of whether the user is a professional archaeologist, amateur archaeologist, or other private individual. Metal detector surveys to prospect for archaeological artefacts can be carried out as a standalone prospection method or as part of the methodology for test excavation or full archaeological excavation. Archaeologists carry out test excavations or test trenching to directly assess the archaeological potential of sites. In contrast to all the previous methods outlined, this is an intrusive methodology. It involves the physical excavation of test trenches using mechanical diggers or occasionally by hand. The purpose of test excavation programs is to assess if archaeological material is present at a site and, where that is the case, provide reliable information as to its location within the site and extent, both horizontal and vertical. Trenching arrays can be either targeted or blanket. Targeted testing is generally carried out where certain archaeological features are expected to be present at a site, so trenches are positioned to best evaluate these expected features. A good example of this in practice is where geophysical survey has indicated potential archaeological features. In such cases, a follow-on program of test excavation would have a trenching array designed to evaluate the results of the geophysical survey. Blanket testing is carried out where there is no expectation of specific archaeological material, but where there is a general potential that archaeological material might be present. Blanket trenching arrays are laid out in an even systematic way across the extent of the subject site and will generally incorporate anything up to 12% of the development site area. A typical example of a blanket testing array would be the centre line with offset arrays that are commonly used in archaeological testing of linear schemes such as new road routes. In both cases, archaeological material found is not fully excavated. Trenches are excavated to the top of archaeological material only, with limited and localised further excavation by hand to assess the depth of the deposits or features encountered. Where appropriate, artefacts or samples may be retrieved for further study. Trenches are backfilled on completion, which protects any identified archaeological remains that are left in situ. Test trenching is legally a form of archaeological excavation, so an excavation licence must be obtained from the National Monument Service for each site. Test excavations can be, and where at all possible should be, carried out in advance of applications for planning permission. They can be carried out as a standalone assessment exercise, including an impact assessment within the testing report, or incorporated into desk-based assessments or environmental impact assessments. Test excavations are also carried out post-grant as part of agreed mitigation strategies and in response to specific planning conditions. In such instances, the testing programme must be completed prior to construction commencing and, depending on the results, there may be a requirement for further mitigation measures, notably archaeological excavation, either prior to or as part of the construction programme. Archaeological monitoring is technically considered a form of prospection, like test excavation, even though it occurs during construction works, as its aim is to identify previously unknown archaeological features. For archaeological monitoring, one or more archaeologists are embedded within the construction team to oversee and observe the groundworks programme, stripping of topsoil, excavation to formation level, and so forth. The archaeologist halts work if archaeological material is identified during groundworks, in order to allow for investigation and recording of such material. Archaeological monitoring is usually carried out under an excavation licence issued by the National Monument Service. This ensures that small finds and minor discoveries can be quickly resolved and recorded with less disruption to an ongoing construction programme. Note, where substantive discoveries are made during archaeological monitoring, however, it may be necessary to suspend certain on-site works until an appropriate mitigation strategy can be agreed with the regulatory authorities and implemented. Archaeological monitoring usually forms part of a mitigation strategy as a requirement of a grant of planning permission. It can be recommended where a site has been through a structured pre-planning or pre-construction evaluation, using some of the methods already outlined in this talk, and no specific archaeological features were identified, but where the potential for archaeological material to be present has not been eliminated with absolute certainty. In general, archaeological monitoring should only be considered a good strategy for sites that have been through such structured evaluations, and this will be discussed further in our next talk on risk management. However, there are cases where archaeological monitoring is the only viable evaluation technique. Examples of this would be infrastructure schemes within the historic cores of our towns and cities. As these projects are carried out within the live streetscape, it is generally not possible to do much advanced prospection to identify archaeology on the scheme routes, so archaeological monitoring becomes a necessity. Archaeological excavation is the comprehensive process for investigating and recording archaeological sites, either in whole or in part. It is often referred to in policy documents as preservation by record. The careful hand excavation of delicate artefacts or archaeological features which can occur during archaeological excavation is the stereotypical picture of the archaeologist at work. In Ireland, archaeological excavation is generally carried out in an open area style by a team of archaeologists. It is a fundamentally destructive process. While some level of reconstruction or retention, mainly of upstanding site features, may be possible in certain circumstances, for the most part, once archaeological deposits or soils have been excavated out by the archaeologist, there is no way to put them back the exact way they were before, so to speak. So archaeological excavation is effectively a one-time process. For this reason, archaeological excavation is undertaken in a controlled fashion using standardized methods and scientifically based processes. Everything is documented using standardized recording sheets, photography, scale drawings, and geodetic survey. Artifacts and samples of significant material are retained for further analysis, and we will discuss this further in our upcoming talk on the post-excavation processes. All archaeological excavations must be carried out under licence from the National Monument Service and in accordance with the method statement submitted as part of the licence application. Professional staff from the National Monument Service can visit an excavation at any point in its progress to confirm that it is being carried out according to the correct standards and in accordance with the approved methodology. Archaeological excavation on development sites is generally only carried out post-grant of planning permission as part of an approved mitigation strategy. It can be carried out as an entirely separate phase of works prior to any construction commencing, or it can be integrated into the construction programme as part of the groundworks phase. The former is most common for greenfield sites, while the latter is more common on urban sites. For the most part, once an archaeological excavation has been completed, then the site in question is considered sterilised. That is, the process of archaeological excavation has recorded and removed all archaeological material present, so development can proceed without further risk to archaeology. The exception to this are sites where a minimum impact mitigation strategy has been agreed. The most common example of this is on urban sites where deep archaeological stratigraphy is present, for example extending 4 to 6 metres below present ground level, or indeed deeper. In such instances, archaeological excavation may extend only to an agreed depth, sufficient for the foundations of the new building to be inserted. Any archaeological material below that level will not be impacted by development and can effectively remain preserved in situ. So in this talk, we have outlined the main methods and practices carried out by archaeologists. Please check back again soon for more talks in this series. Our previous 2 talks, firstly outlining what archaeology is, why it's considered important and the legislation protecting it, and secondly looking at archaeology in the planning process, are already available for you to watch. Upcoming talks will look at risk management for archaeology in construction projects as well as construction contracts, outline what is involved in post-excavation analysis and why it is a critical part of the archaeological process. If you want to find out more about archaeological methods and practices, there is a list of links to further resources in our blog post for this talk.